Hello students. So today we'll study chapter number 7, Air. This is for class 4 students. Let us begin this chapter with a warm-up activity. Alright, so a warm-up activity is in front of you. So here some pictures are there. First is a picture of the fire. And we have to put a tick on the ones that need air. So I have done this activity for you. So you also can write in your reader. Fire, yes, it needs air. Plant, yes, it needs air. Football, yes, it needs air. But a chair, which is a non-living thing here, chair, does not need air. All right. Okay. Now, let us focus on the word air. What is air? Air is all around us. Everything has air. Even an empty bucket, empty container, anything you see empty, but there is air inside it. Alright, we cannot see air, but we can feel it. But the blanket of air around us, that is called atmosphere. Alright, the blanket of air around us is called atmosphere. Right, so today we'll learn about some properties of air, which is very important for our survival. Air is very important because we breathe with the help of air, and without air we cannot live. Right, so let us learn about some properties. First property, air is colorless, odorless, and tasteless. Colorless because there is no color to air. You cannot see any color in the air. Odorless because you cannot smell it. You cannot smell air. Alright. And then tasteless means there you cannot taste it. Even if you engulf air is in your mouth, you cannot taste it, make out any taste out of that. Alright. Now we cannot see air, but we can just feel it. How do you feel it? We can see the effect of the air in the rustling of when the air is rustling through the leaves of the trees. Okay, when we see the trees are swaying, when we are running fast, we can feel the air. When we switch on the fan, we feel the air. So here we can just feel the air, okay, when it moves, all right, or moves things around us. All right, so let us learn some properties of air which make us feel its presence. Okay, some properties which make us feel its presence. Here, before that, let us do this find out question here. A find out question is given. What is the effect of air on the waves in the sea? All right, this waves which you see, no? Sea is there, you just see the waves here. This waves is due to the fast blowing air which is called wind. This wind creates these waves. The faster the speed of the wind, the larger will be the waves which you see. All right, you must have seen on the coastline, okay, the sea waves. This is because of wind. All right, let's go to the next page here. First property we have already learned. Air is odorless, colorless, and tasteless. Now this is the second property we are learning here. Air occupies space. All right, air, like any matter, okay, whatever see, matter is anything which we see around which has weight and occupies space. So air is also matter. Okay, air is also matter, and it also occupies space and has weight. Let us find it out. All right, so air, like any other matter, occupies space. All right, an empty glass is not really empty. There is air inside it. So let us prove this with the help of an experiment. Take a balloon like this, okay, a deflated balloon. What do you mean by deflated? What do you mean by deflated? Deflated means which has no air inside it. All right, no air inside it. Okay, so now this deflated balloon, start blowing air in it. Now when we start blowing air in it, what happens to this balloon? It will increase in size. So that shows that the air occupies space. So the volume of the blown balloon, is the volume of the air inside. Now what is volume? The amount of space occupied. Okay, the amount of space in the balloon is the amount of air in the balloon. All right, so this experiment proves that air occupies space. Let's get to the next property. This is the third property. Air has weight. Okay, air, like any other matter, has weight. Yes, it does have weight. It does has weight. Yes, so let's prove it with this experiment here. Okay, we'll try making a balance like this with the help of a scale. You have seen a balance, no, with the green grasses? Yes, so this is the balance which is made of the scale. In the center, a rope is tied here, and here two balloons are tied. All right, this is the second case here. First, it looks something like this. All right, and here on the side, two balloons are filled up balloons are tied like this. All right, like this. All right, now what we will do next, we will try taking out the air from one balloon like this. We'll loosen its mouth so that the air moves out. So after that, what do we see then? Then we see that the in here two terms I'm using in front of you. One is deflated. Deflated means when there is no air. So the first balloon is deflated now. And inflated, I'm using this term in front of you. Inflated means now that is filled with air. So I'll be using this term, so understand the meaning. So this deflated balloon, the first one, that moves up, and the inflated balloon, which is still filled with air, moves down. So this experiment shows that air has weight. All right, students, now let us learn the next property now. The fourth property here. Air exerts pressure. Now, anything which has weight exerts pressure. Yes, even our body has weight. So our body also exerts pressure. That is why we are surrounded by air and our body is not crushed by the air pressure, because our body also exerts pressure and air also exerts pressure. This is, for example, a human body here. So air exerts pressure and even our body also exerts pressure. So it gets balanced. That's why we are not crushed by the atmosphere around us. Alright, students, now there is one more interesting thing about air pressure, that air pressure is highest near the surface of the earth and it diminishes means becomes less as we go up. Alright, so here the earth's surface, and as we go up, for example, we are going up to the mountain, high mountain, then the air pressure decrease. Why? This happens because of the gravity of the earth. This happens because of the gravity of the earth. For example, I'm just drawing a diagram here. Okay, here. So earth's gravity is the force of the earth which pulls everything towards itself. We are standing on the earth straight. Why? Because of gravity of the earth. So here, gravity of the earth pulls the atmosphere towards itself. So here, so closer to the earth's surface, the air molecules will be more. Air molecules will be more. And on the top here, when we go at heights, no, then the density of air becomes less. That means lesser of the air molecules. So when a thing is less, it will exert less pressure. That's why as we go up, the pressure decreases. Alright, so pressure is most near the earth's surface, and it decreases as we go up because of the lesser molecules of air or lesser density of air at heights. All right, students, so this was a property of air, and this also can be shown with the help of an experiment. Yes, so here's an experiment for you. So here you can take a glass, and you can fill it with water, and fill it with water to the brim. That means till the end you fill it completely with water, so that there is no air in the glass and no air in the glass, and only what should be there? Only water should be there. completely filled till the top. Now put a cardboard on the mouth of this glass, and then holding this cardboard, turn this like this. Turn this now like this glass and remove your hand, and you can hold the top of this glass, and you will observe that the cardboard is not falling down, and neither the water in the glass is falling down. The water will be intact in the glass and also the cardboard. Why? This is because the pressure exerted by the air is more than the pressure of the water molecules inside. So this pressure is more. That's why the water is not coming out, water is not spilling. Alright, so this is the example of what? Air pressure. Now air pressure can be shown by various things. One more experiment you can do when you are using a straw. Okay, I'll just zoom it for you a little. If you can see this picture, yes, this one I'm talking about. Yes, now when you are drinking a cold drink, you're sucking through the straw. Straw is that? What is straw? Yes, here. Straw is a pipe which you use for sucking juice. So what happens when you suck through the straw? You are sucking all the air from the straw. Now the straw is empty. Now this air pressure, outside there is air, no? So this air will put pressure on the liquid here. Air will put pressure on the liquid here, and that will cause the liquid to rise up in the straw, which has vacuum, which was created by you. You sucked up air from the straw, and there is vacuum in the straw now, and this air pressure forces this liquid to move in the straw here, and you can drink the juice. Alright, this also happens because of the air pressure. Now there are some more examples of the use of air pressure. Now here is some examples. The pictures are given here. Filling a syringe. A doctor is using a syringe to give you injections. Alright, she's filling a medicine in this. Alright, and then injecting in your body. This also requires air pressure. Okay, even the hand pump which we are using for taking out water requires air pressure. Vacuum cleaners also require air pressure. Alright, even the aeroplanes, sailboats all require air pressure. Alright students, here's a picture here like this. This is the picture of a hand pump. So because of the air pressure, here water is there in this underground, water is brought up and it comes out through this nozzle here. Alright student, so here this was a picture of a hand pump. This is a picture of an aeroplane. Aeroplane also moves because of the air pressure, because the air pressure on above its wing is more and down more than the pressure below its wing. So that's why it is able to lift itself in the air. So all these are the examples of what? Air pressure. Alright, okay, right student. So here now let me take you back to the page where we are. So these were the examples of air pressure. Now students, let us learn the next property of air. Air expands on heating. What do you mean by expands? That means increases in volume. Increases in volume on heating. So here, so let us take an example. Again, an activity we will do to show that air expands on heating. Here I have one diagram for you to explain you this. Alright, can you see this diagram here? Yes. Now here, what we have taken a bottle. Okay, and on the mouth of the bottle we have tied a balloon. Nicely we have tied on the mouth of the bottle a balloon here. Right, this balloon is tied from here. Right, just now you can see before heating the balloon is squeezed up. No air is there in the balloon. Okay, air is there in the bottle. The balloon is deflated without air. Now, as we will put this bottle in this hot water, what happens? This balloon, you can see, gets inflated. Inflated means filled with air. That shows that air expands on heating. Now, how it is happening? Now, the air molecules inside this bottle, no, air molecules are spread in a gas. They are not tightly packed, they are loose, very loosely packed. Now, when it gets heated up, these air molecules get heat energy because of this hot boiling water. Then these air molecules start moving faster, and as they start moving faster, they further go apart from each other, further grow apart from each other. For example, here they will further go apart from here, they will go here, further go apart from each other, and then they will become lighter. Warm air is always lighter, so it moves up and occupies the space in this balloon, and the balloon gets inflated. All right, students, so this shows that air expands on heating, air increases in size on heating. All right, okay. Now, here, let us learn about, after this, let us learn about the composition of air. Before that, you can see a revision zone is given there. Answers are written, you can just go through it. Okay, now the composition of air. Air, what do you see, what you feel around? That is a mixture of gases. Okay, now here is a pie chart. What is a pie chart? You can see the circular chart. You must have seen the bar graphs and bar graphs also. You must have seen the bar graphs like this, and these are the for graphical representation of any data. Now this is a pie chart which is showing the composition in the form of percentage. Okay, so this you can see the bigger brown area. This is the percentage of nitrogen present in the atmosphere, which is 78%. And this, can you see this other color here, light brown? This is 21% oxygen is present here. And this very thin part here, this is 1% other gases, which contains carbon dioxide also, hydrogen, not oxygen, sorry, ozone, neon, argon, helium. All these other gases are present in this 1%. So what is the major proportion of which gas is there in the air? Nitrogen, and then oxygen. All right, so this is the composition of air represented through this pie chart in the form of percentage, right? Okay, now here, and only 0.04% of carbon dioxide is there in the atmosphere, which is required by the plants also. Okay, right. Now air also contains water vapor. All right, and this amount of water vapor in the atmosphere is called humidity. All right, so this water vapor in the atmosphere, that varies. All right, all the places do not have the same amount of water vapor in the atmosphere. The coastal areas, or where it rains much, there you'll have in the atmosphere lot of water vapor, lot of humidity. And when a place is humid, no, with lot of water vapor, then if you sweat in such areas, no, your sweat does not dry up, because already there is a lot of water vapor in the atmosphere, so it does not absorb more water from anything around. All right, that's why your sweat does not get dried up in the humid climate, and your sweat evaporates easily in a drier place, because sweat is what, nothing but water liquid only, no, so it gets evaporated faster in a dry condition. All right, and air also has dust and smoke, which is created, it's created by the smoke is created by the vehicles, the factories and all, that is polluting the air. Okay, so the more the dust and the smoke, the more polluted is the air. All right, now nitrogen, which is in the most proportion in the air, is very, very essential. okay, for the living organisms, okay, especially for the plants here, because we eat plants and through that we get nitrogen. All right, and these plants cannot absorb nitrogen from the air directly. They absorb nitrogen from the soil, because this nitrogen is converted into a usable form like nitrate and ammonia. I'm writing here nitrate and ammonia through the bacteria present in the soil. And after that conversion only, we can these plants can absorb this. Nitrogen is very essential in the formation of protein, and protein is very much required for our growth, okay, for the growth of the plant, okay, and also for us also. All right, so this was all about air, the properties of air and the composition of air. The remaining topics I will take and discuss in the next video. I hope you have understood the chapter up till here.